Let's look at an example configuration in our live environment. R3 is our boundary router. It's sitting on the edge of the EIGRP autonomous system and the OSPF domain. So this is the router we're going to perform redistribution on right now. And I want to focus on those EIGRP routes. I want to redistribute those EIGRP routes into the OSPF domain. So we're going to use R7 as our verification router. So if we click on R7 right now and we look at the output of show IP route, we only have one external route listed. And that external route is the default route that R4 is advertising. That's the only external route we know. But we want to perform redistribution on R3, so R7 will have the 10.1.1.0, the 1.16, the 1.32, the 1.48 networks. So everything that's in the EIGRP autonomous system, it's going to appear as OE2 routes right now in our example. So let's go to R3, configure terminal, router OSPF1. Well, before we even do that, let's look at R3's routing table. Let's see if R3 knows about those EIGRP routes, first of all. Because if it doesn't know about those EIGRP routes, or more specifically, it's not using those EIGRP learned routes, then it won't be able to redistribute them. So show IP route EIGRP, and you can see all of the EIGRP learned routes. So 10.1.1.0/28, 16, 32, 48, they're all there. So these are the routes that are going to be redistributed into OSPF. So configure terminal, router OSPF1, and we're going to say redistribute. And as we saw earlier, when we redistribute, we have all these routing sources that we can import information from. In this case, it's EIGRP. It wants the autonomous system number of 100. And then here's the options we've already reviewed. So, just to recap, do I need a metric? No, because the default metric is 20. Do I need a metric to specify a metric type? No, because the default metric type will be E2. Do I need a route map? No, the route map gives me granular control of the different routes as we perform redistribution. If I don't specify a route map, then whatever's in this redistribute command will affect who? Or what routes? All of the routes. Do I need a tag? No, I don't need a tag. Do I need the subnet's keyword? Depends. That's the answer. Depends. Depends on what? Depends on whether I have classful or classless networks that I'm trying to redistribute. Let's scroll back up. Are these classful or classless networks, folks? Yeah, they're classless. And that's the 10 network. It's Class A. For it to be classful, it would need a /8 subnet mask. But no, these are classless, not classful. So let me show you what happens if I don't specify the subnet's keyword in this case. It says only classful networks will be redistributed. Well, none of those are classful, which means if we go over to R7 now, let's do that, and we type in show IP route, nothing has been redistributed. Nothing at all. Let's go back to R3 and add the subnet's keyword so you can see the difference here. Now that the subnet's keyword has been added, if you go back to R7, oh wow, look at all the E2 routes now. Specifically, let's focus on those routes from the 10 network. They are right there. So we successfully redistributed on R3 those EIGRP routes. And they're appearing as OE2. Let's modify this redistribution command now so you can see the difference. What are the other options we have, as we mentioned? Metric. We said the default metric for OSPF is 20. Let's prove it. Go over to R7, go back to those 10 networks. There they are. It's 20. Now, wait a second. You might be saying, well, that doesn't make sense, Raymond. Because if we look at the topology, if we are putting a metric on R3 as 20, why aren't the routers adding the costs of all the other interfaces along that path? It shouldn't be 20 once it reaches R7. That's the difference between E1 and E2, as we'll see. E2 routes preserve the metric that is introduced at the redistribution point. E1 routes will add up all the different costs along that path and add it to that metric that's introduced at the redistribution point. We'll discuss that here shortly. But right now, it's 20. So what I want to show you is how we can modify that. So let's go over to R3, and we'll say metric. Metric what? It's looking for a metric. Let's just put 35 for fun. So now that I've put 35, let's go back to R7. If we look at the output of show IP route, you can see those 10 networks now have a metric of 35. Let's change the metric type over on R3 so we can show you that as well. If we change the metric type, right now it's currently E2. Well, if I say type 1, it changes it to an E1. If we go back to R7, look at the output of show IP route, notice they're now E1s, all of them. But more importantly, the cost is cumulative now. We started off with 35 plus the cost of the link between R4 and R3, then the cost of the frame relay links between R4 and R5, and then the cost of the Ethernet interfaces between R5 and R7 for a grand total of 101. Any other options? Yeah, we can still apply a route map if we want to. We'll discuss route maps later on. And we can still apply a tag. So let's just recap what we covered here. Very, very important to include the subnets keyword. As we saw, if you don't include the subnets keyword, only classful routes are advertised. There is a default seed metric of 20, but if you want to change that metric, you can change it with the metric parameter. The default metric type is E2. But if you want to change it, you can change it with the metric type, specify E1.